Hi, everyone. This is Mr. Burris. We're going to go over a new topic today called Earth and the Sun's Energy. Earth's movement. Energy from the sun helps crops grow, provides light, and warms Earth. It even influences the clothes we wear, the foods we eat, and the sports we play. All life on Earth requires solar energy or energy from the sun to survive. The amount of solar energy places on Earth receive changes constantly. Earth's rotation, revolution, and tilt, as well as latitude, all affect the amount of solar energy parts of the planet receive from the sun. Rotation. Imagine that Earth has a rod running through it from the North Pole to the South Pole. This rod represents Earth's axis, an imaginary line around which the planet turns. As Earth spins on its axis, different parts of the planet face the sun. It takes Earth 24 hours or 1 day to complete this rotation. A rotation is one complete spin of Earth on its axis. As Earth rotates during this 24-hour period, it appears to us that the sun moves across the sky. The sun seems to rise in the east and set in the west. The sun, however, does not move. Well, kind of. It does move around the center of the Milky Way galaxy with the rest of our solar system. It is actually the Earth's rotation that creates the sense of the sun's movement across our sky. Earth's rotation also explains why day changes to night. As you can see in the illustration, solar energy strikes only half of the Earth facing the sun. Warmth and light from the sun create daytime. At the same time, the half of the planet facing away from the sun experiences the cooler temperatures and darkness of night. Earth's rotation causes regular shifts from day to night. As a result, levels of solar energy on Earth constantly changes. Revolution. As Earth spins on its axis, it also follows a path or orbit around the sun. Earth's orbit around the sun is not a perfect circle. Sometimes the orbit takes Earth closer to the sun, and at other times the orbit takes it farther away. It takes 365 and 1/4 days for the Earth to complete one revolution or trip around the sun. We base our calendar year on the time it takes Earth to complete its orbit around the sun. To allow for the fraction of a day, we add an extra day, February 29th, to our calendar every 4 years. We call this leap year. Leap year always has the Summer Olympics as well as a U.S. presidential election. Tilt and latitude. Another factor affecting the amount of solar energy we receive is the planet's tilt. As the illustration shows, Earth's axis is not straight up and down. It is actually tilted at an angle of 23½ degrees from vertical. At any given time of year, some locations on Earth are tilting away from the sun, and others are tilting toward it. Places tilting toward the sun receive more solar energy and experience warmer temperatures. Those tilting away from the sun receive less solar energy and experience cooler temperatures. A location's latitude, the distance north or south of Earth's equator, also affects the amount of solar energy it receives. Low latitude areas, those with low numbers, near the equator, like Hawaii, receive direct rays from the sun all year. These direct rays are more intense and produce warmer temperatures. Regions with high latitudes, those with high numbers, like Antarctica, are farther from the equator. As a result, they receive indirect rays from the sun and have colder temperatures. This map shows you where the high latitudes are and where the low latitudes are. High latitudes, these are locations on Earth with a latitude degree higher than 60, are near the poles. Low latitudes, these are locations on Earth with a latitude degree lower than 23½ near the equator. These are also called the tropics, so low latitudes are near the tropics, high latitudes are near the poles. Seasons. Does the thought of snow in July or 100-degree temperatures in January seem odd to you? It might if you live in the northern hemisphere where cold temperatures are common in January, not July. The planet's changing seasons explain why we often connect certain weather with a specific time of year, like snow in January. Seasons are periods during the year that are known for a particular type of weather. Many places on Earth experience 4 seasons: winter, spring, summer, and autumn, or fall. These seasons are based on temperature and length of day. In some parts of the world, however, seasons are based on the amount of rainfall, like in the tropics. In this model, you can see the Earth's axis. When the Earth's axis is tilting toward the sun, as this model shows, the northern hemisphere is tilted toward the sun, you have summer. In this picture over here, the northern hemisphere axis is tilting away from the sun. Therefore, you have winter. The spring and fall equinoxes are receiving both hemispheres the same amount of sun. Winter and summer. The change in seasons is created by Earth's tilt. As you can see in the illustration, while one of Earth's poles tilts away from the sun, the other tilts toward it. During winter, part of Earth is tilted away from the sun, causing less direct solar energy, cool temperatures, and less daylight. Summer occurs when part of Earth is tilted toward the sun. This creates more direct solar energy, warmer temperatures, and longer periods of daylight. Because of Earth's tilt, the northern and southern hemispheres experience opposite seasons. As the North Pole tilts toward the sun in summer, the South Pole tilts away from it. As a result, the southern hemisphere experiences winter. Likewise, when it is spring in the northern hemisphere, it is fall in the southern hemisphere. Solstices and equinoxes. Winter solstice. This marks the onset of winter. At the time of the shortest day, about December 22nd in the northern hemisphere and June 21st in the southern hemisphere. Summer solstice marks the onset of summer. At the time of the longest day, about June 21st in the northern hemisphere and December 22nd in the southern hemisphere. The equinox, the time or date twice each year at which the sun crosses the celestial equator, when day and night are of equal length, about September 22nd and March 20th. Spring and fall. As Earth orbits the sun, there are periods when the poles tilt neither toward nor away from the sun. These periods mark the spring and fall equinox. During the spring, as part of Earth begins to tilt toward the sun, solar energy increases. Temperatures slowly start to rise, and days grow longer. In the fall, the opposite occurs as winter approaches. Solar energy begins to decrease, causing cooler temperatures and shorter day. Rainfall and seasons. Some regions on Earth have seasons marked by rainfall rather than temperature. This is true in the tropics, regions close to the equator, known for the low latitude numbers, 23½ degrees or less. At certain times of the year, winds bring either dry or moist air to the tropics, creating wet and dry seasons. In India, for example, seasonal winds called monsoons bring heavy rains from June to October and dry air from November to January. The midnight sun. Can you imagine going to sleep late at night with the sun shining in the sky? People who live near the Arctic and Antarctic circles experience this every summer when they can receive up to 24 hours of sunlight a day. The time-lapse photo below shows a typical sunset during this period, except the sun never really sets. This phenomenon is known as the midnight sun. For locations like Tromsø, Norway, this means up to 2 months of constant daylight each summer. People living near Earth's poles often use the long daylight hours to work on outdoor projects in preparation for winter, when they can receive 24 hours of darkness a day.